Are you able to see?
No, sir.
But I have shared. Let us wait. You are not able to see it?
Yes, sir. Yes. Right now it is seen.
Okay. So, good morning once again, everyone. Today, I'm going to talk about another topic which is related but slightly different. So, automation and intelligent systems. So, I'm planning to cover some of the topics like this. I'll briefly introduce you to what is automation, what are the types of automation with some examples. Then I'll talk about the standard ISA 95. Then my own case studies from past as well as from current company. And then in past, when I was in Infosys, I was working on automation of CAD, CAM, CA softwares. What is that? And what is that automation? And then I'll talk about now in beyond the industrial automation in a mechanical industry, there is in IT industry, there is a kind of another automation called robotic process automation. What is it, how it works, how it helps, that I'll talk. And then I'll talk about intelligent automation. What is this intelligence? That is artificial intelligence and how automation and artificial intelligence will work together to create the intelligent system. Let's see. Automation. So I just said, so if you remember, the transformation in the industry is happening, digital transformation, I said, and as part of digital transformation, there is another revolution happening, that is automation. And automation is having its own benefits because it can improve your productivity, it can be repeatable, it can be it can improve your product process and so on. So the automation can be at machine level, automation can be at process level, automation can lead to the innovation, or automation can be autonomous. So I have been working across some of these automations, and I'll be sharing that, some of the case studies. So before going into that, let's see.
These days, many industries are automated. Their whole process is working automatically with minimum human intervention. And in the days to come, it will become more and more developed. Just see a Pepsi factory as an example. From preparing compound or liquid to filling it in bottles and packing, every stage is automated. No need for humans to measure the quantity of liquid, capping and label the bottles, and count the bottles. All tasks are done automatically. But how is it possible?
So this is what we'll see. What is this automation, how it happens, how people do and all that, or how we did some of the automations. So what is automation? Probably it's said, so if you trace back the word automation, is derived from the Greek's automation, meaning self-moving. Auto means self, matic means moving. So automation, if you have seen earlier example where Pepsi factory example, I'll take you through another factory later. And if you see some of those factories, definitely use a lot of automation where the production is huge. So automation happens, and maybe when you attended my Industry 4.0, I said, we talked about Industry 2.0, where I said mass production, assembly line, that was more of a mechanical automation. So over the period of time in Industry 3.0, electronics and computers start coming into picture. So that's where, so the automation is use of technology and machines to perform tasks or processes without human intervention. So that's where the automation started growing a lot in the era of Industry 3.0. In Industry 2.0, it was not that because it was mainly the mechanical technology part was not that predominant. So whatever the automation could be done using mechanical systems. So if you remember the old, even today in India, some of the places you will see that tank, water level tank, right? It is operated using mechanical control system, right? So ball is there as water fills up the all cutoffs, right? So that kind of automation was very predominant in Industry 2.0, but in Industry 3.0, the automation which combines technology and machines together started coming into picture, and that's what we are going to talk today. We're going to talk about the automation which combines the technology and machines. So it's obvious it involves all hardware and software. At hardware, it's more of sensors, robots, and at software, probably it is any kind of computer program. It can be anything. And generally, automation typically happens on some rule-based task, whatever. If you can define a rule, if you can define, so that's what I used to call when I was working for Infosys, and we were doing this automation for I was majorly working for aircraft programs, Boeing, and Boeing has something called knowledge-based engineering. So that emphasis is on automation of some of the software. So I generally used to say, if you can define your task in a rule, then definitely you can automate it. If you can't define in a rule, then automation becomes a difficult task. So that is why generally automation is rule based. So the goal, of course, I said in earlier slide also, it improves efficiency, productivity, and accuracy while minimizing errors and saving money. And you can see automation. Probably I'm the kind of automation I'm talking today, knowingly or unknowingly, it is part of your life. If you see that's there, you may notice or may not notice. For example, I give you a simple example of your emails, right? So you have in a Gmail, if you go, there are three folders you can see probably. One is social, one is spam, then there is maybe junk also, then there is a inbox, right? So your email filtering, of course, started happening already automatically, right? That's automation at a software side, which is more like I call it as probably robotic process automation, which is a very widely used in IT industry. And then there can be, then we saw on the first day, right? Most complex automation, most complex process of automation, that's autonomous vehicles, right? So it is everywhere. I mean, you are already already the part of the revolution. You are already the part of the automation. It's not that you are not using it. You are knowingly or unknowingly using this. So hence probably the automation is a key driver and for moving ahead, making the progress, creating the innovation. So let's go into some more details. So this is the one example how automation can help.
Just
So
look at a boiler's
in UK homes, mostly are in your homes also geysers, right? In UK homes, there is definitely every home has a boiler, and boiler is constantly maintained and at a certain temperature level, and using the home automation systems.
operation manual control. It has a temperature gauge and a handle valve to control fuel. A human must be there to look at the temperature gauge and control the handle valve. He will close the valve upon the temperature reached the required value. So think about the risks. Only a human is responsible for the whole action. The temperature can't be accurate. There are chances of human error. Can't handle if we need to control a large number of valves. Human is there at a boiler that is not safe. The life of humans is at risk. Now see automatic control. The temperature gauge is replaced with a temperature transducer. The handle valve is replaced with a control valve, and the human is replaced with a temperature controller. Yes, human is replaced with temperature controllers. And they all are connected through wire and power supply. The required temperature is already set at temperature controller, that is called SV means set value, and temperature transducer send a signal of current temperature, it's called PV means processing value. When PV reaches the SV value, a signal will transmit to the control valve, and the valve will be closed automatically. So the same action has been done without humans. So human is in a safe place. No chance of errors, the temperature will be accurate. Can handle a large number of valves.
So in UK homes, the boilers of my height are almost there in every home, because the outside temperature is very, very cold, and always need to have every home will have two taps, hot and cold tap, and you need always hot water, because you can in at least winter you can't use the cold water. So that is the situation where you can use this kind of automatic control or home automation systems.
Just look at a boiler.
So what are the types of automation, and where are they used in the industry? Types according to the kind of features they implement, or types where they are used. So as per the application, let's say industrial automation, service automation, home automation, business process automation, or transport automation, or hospital automation. So based on logistic automation, there can be many types based on application, but typically the way it is done, the way it has a functions and features and functionalities, it can be fixed automation, it can be programmable automation, it can be flexible automation, it can be robotic automation, it can be cognitive automation, and it can be autonomous automation. So as basic, it can be a fixed automation, one end, and another end, that's autonomous automation. So you have seen like boiler, what you have seen boiler is a fixed automation, or it can be probably converted into a programmable automation. Or the autonomous vehicle on Monday, which I have explained, is a state-of-the-art automation, which is a complex automation, transport automation, right? So that kind of, it's autonomous automation need not to be just always in transport. There can be many autonomous operations in the industry or in any other field, and that is what you can. Everything will be so. When you in a traditional automation, when you embed a cognitive features and combine together these basic automations, either fixed or programmable, by combining the cognitive features and then doing it will lead to the autonomous, or doing it more autonomously as if human is doing. So that's autonomous. So let's see each one of it. And before really going into these details, I want to take you through one of the most state-of-the-art automated factory which I have visited. Although this is a video from SKF India, Bangalore, but in 2017 I was in Germany, and I had a chance to visit the SKF because we were working for them for designing of bearings. And then I had also chance to visit this Bangalore factory. When I first time visited German factory, I realized the level of automation they use and why they use. It is amazing to see. So probably I'll just play this video and then I'll give more insight into it.
SKF Bengaluru to reach its goal of 0 defects. Once the components are assembled, the bearing is marked with standard SKF . The bearing goes through the check for noise levels and internal clearance. The bearings are moved to the finished product store, where they are packed for sea and air shipments. Highly sensitive calibrated weighing machines confirm the right quantities are packed and shipped. The enterprise resource planning.
So you can see the kind of automation they use. So I have seen the factory, you have seen on the shop floor, right? The very few people would be there. In fact, in this video, you can see a few more, but back in Germany, when I saw probably one shop floor, we had only a couple of guys who are just monitoring the machines or just checking if something is going wrong. So from start to finish until packaging, everything is automated. Everything is automated. Assembly, greasing, packing, plastic, packing in plastic, packing in the boxes, packing in the big boxes. Everything is probably automated. So it's amazing. I mean, if you get a chance to visit, if you are in Pune, or if you are in if you can visit to the Pune also has a similar automation factory. So definitely it's worth to see and understand the kind of automation they do, the way they do with the precision and accuracy, even their measurements, inspection, all the activities are throughout all automated. Only people are there to monitor the machines, monitor the settings, monitor if there is any problem in the line, just to, people are, the operators are not really doing any manufacturing related activities. Only people are doing probably some kind of inspection, monitoring, surveillance activities. So that's the kind of
delivering
that's the kind of automation you will see into the industry. So that's amazing to see that and understand. So let's go through each type briefly. So what is a fixed automation? Is designed to perform specific tasks repeatedly, kind of what you have seen into the some of the activities of the Pepsi video or the SKF video, and high volume manufacturing, right? So if you want to know the number of bearings they produce per year, somewhere I remember they produce around 20 30 crores of the bearings each year, right? Now imagine per day production they required, and to do that, it's certainly not manually possible, right? The same is true about Pepsi. Say they need to produce crores of cold drinks every year, so definitely they need to completely automate it. It's not certainly such kind of highly repetitive task is not certainly the task of human people, right? And that is why, I mean, you will come across many industries like automotive, electronics, food processing, even this kind of automation you might see into some of the electronic manufacturing companies or food companies. That's the same thing. Then there is a next level of automation. These are fundamental automations typically widely used in any industry, and that is where you will see programmable automation you will use into the when you can program it, reprogram it for a different purpose, right? Not just the fixed automation. The problem is if there is a slight variation, or if there is a variation in the product or operation, then you can't use that. Probably you will have to do another automation, right? But in the programmable automation, you can probably do the multiple tasks by reprogramming it. And this is generally can be seen into the manufacturing factories where the tasks are frequently changed. So they will ensure that way automation is set up, which allow them to program and perform a different task. The third fundamental automation is a flexible automation, is a combination of fixed and programmable, and it is designed to perform variety of tasks that can be reprogrammed or adapt to the changing condition requirement. For example, if the diameter changes, right, say, or height changes, then it will try to adapt to the changing requirements or changing task, right? And if the flow of operation changes, it can be reprogrammed that way. So these are widely used in pharmaceutical, consumer goods, and many of the aerospace activities. So here is then that is those probably fixed automation definitely was a part of industry 2.0, programmable and flexible. started coming into early days of industry 3.0, and as industry 3.0 started maturing with a lot of use of computers, robotics, and electronic systems, right? So then robotic automation came into picture, and robotic automation involves use of robots to perform various tasks that are either too dangerous or too repetitive for humans, right? So for example, bearing manufacturing, it's too repetitive, maybe not too dangerous, say, but there can be too dangerous activities also, right? So heavy, probably that heating, early heating of the bearing material, right? So it is a too dangerous, right? Or something welding kind of operation, it is too dangerous. So maybe those kind of automation, robotic will definitely certainly useful, or highly repetitive also robotic is. So it can be used in variety applications like manufacturing, healthcare, logistics, everywhere. Or logistics, definitely robots. You might have heard stories, I don't know, but I have seen that in Amazon warehouses. In Amazon warehouses. So I was selling on Amazon, so I know that some of my products I told probably on day one. I was manufacturing many products and VR headsets and selling on Amazon. So Amazon factory, warehouses are highly robotic, highly their process. So many, sometimes you might wonder, you place an order, probably next day you get a delivery. And how is that possible? So that's because of highly robotic automation into the warehouses of Amazon. If you are ordering something which is coming from Amazon warehouse, not every product will come from Amazon warehouse. Some products will directly come from the seller's factory, but some products will come from Amazon warehouses. So if the product is coming from Amazon warehouses, so you are not surprised if you are placing order tonight and you are receiving by tomorrow lunch. That's because the moment you place an order, it started already processing at a warehouse, because it is done by the robots, right? It's not like, okay, it's not time of operation. The moment you place an order, in 30 minutes of your processing order, the system will confirm your receipt of order, receipt of payment. The robot will get an instruction. It will start its operation of picking from the location in the warehouse, start packing and creating labeling, and everything will be done, and it will be ready for dispatch. The next day, when morning the logistic transport people comes, delivery guys comes, it picks up those products and delivered to you. So that is how it happens. So robotic automation in logistics is very, very, very widely used nowadays, and Amazon is one of that. Even you have seen in that escape bearing, there is another section which I remember. The whole process of packing and shipping of bearing boxes is completely automated in escape bearing. So many companies does that. So robotic automation has been phenomenal of late. In another example, probably if I remember, in Infosys, we were exploring the robotic automation, robotic applications in different fields. So one of the field which not widely used, that's banking sector, right? So in the banking sector, different kind of robotics is used: cognitive, automation is widely used, which I'll talk. But we were trying to create an application, and we successfully created our. I was certainly not part of that project, but I am aware of that project. So the project is we had this robotic arm the way you see here, and this robotic arm. So where you will use robotic arm in a banking, right? So our team was trying to do so the credit card, debit card system in the banks, right? So how these cards are tested, right? And you have to be very careful. You have to do a lot of testing of these systems before it really does. So we built a robotic arm which can do that card testing repetitively. So it from the manufacturing, from this configured card, it will pick up the card, robotic arm will pick up the card, swipe it, check it works, insert its number or its pin, everything, and then all operation it will do, and it will confirm whether if that whole process goes successfully, it will put into the bin where it is tested okay, and it will put into the bin if something fails, it will put into the bin where test fails, right? So that kind of robotic automation is growing in last 1 or 2 decades. So here is another example from our own factory here. We call that factory 2050, which is our nuclear AMRC, one of the research centers. Another branch, it's manufacturing research center. So it is completely highly robotic. Everything is robotic, and we call that as a factory 2050. Means probably the factories of 2050 would be completely robotic. And what should be done for that?
I'm Ben Morgan, and I'm the Research Director at the Advanced Manufacturing Research Centre. Our directors back in 2013, 2014 were involved in a report for the government to understand what the future need for manufacturing was in the UK. The report concluded that there was a need for skills and to attract the right talent into the industry, and that manufacturing was heading towards a need for reconfigurability and a much more digitised production methodology. And so Factory 2050 was really born out of that. The research and development being carried out in Factory 2050 is mainly based around assembly technologies,
so you can see the kind
and
of
the smart or digital
parts
factory
robots can
concept.
handle
There's a lot
in
of
our
automation,
Factory 2050.
robotics, a lot of measurement, inspection, artificial intelligence and general data analysis informatics carried out within the facility. Factory 2050, I would say, is at the cutting edge of using artificial intelligence in the UK, and that's due to the fact that we're reaching down into some of the academic research that we're doing within the university to really push the boundaries of what's possible with AI for our industrial partners. One example of that is quality inspection, where we're starting to now get figures back showing that AI is actually more responsive and more accurate than the human operator.
You can see collaborative
Another
robotics.
is in a maintenance
These are all actually
application
the robots
where we're
working in
starting
our
to use natural
factory.
language processing to really guide and aid the operator in their use of digital technologies. There's been a huge drive by the UK government with industrial strategy to push the productivity and prosperity of the UK economy through manufacturing. And I think Factory 2050 has been a flagship really in showing to the UK and the wider world what digital manufacturing can do. I think the next exciting thing for Factory 2050 is some of the work we're doing around digital meets manufacturing, where we are linking up some of our manufacturing companies and partners with small digital businesses in the region and nationally. What we're seeing is some of those smaller businesses have solutions and can act very, very quickly and solve some of our manufacturers' issues. I think that will be revolutionary for the UK going forward.
So that's our Factory 2050, and it's a completely robotic automation, probably augmented with cognitive automation. So what's the cognitive automation? It uses AI and machine learning. I'll talk in detail a bit later. What is AI? What is machine learning? What is deep learning? To automate the tasks that require human-like decision making. So rule-based probably is not cognitive, probably flexible, fixed, programmable. It's rule-based, right? Probably a lot of robotic also is a rule-based. So you define certain rules to perform a task and it will do the task. But many tasks need human-like decision making, right? Human-like reasoning. And that will come from artificial intelligence. And that is growing slowly. So I said, right? And this kind of cognitive automation, although growing in factories and hardware part of it, but it's very popular today in software side of it, in many companies, IT side of any company like finance, healthcare, customer service. So you might have seen these days, when you go to some company's website, chatbot comes, right? Now that chatbot is a type of automation for a customer service. Or many times you might have gone to some finance websites, they tell what should be your credit score, or maybe which policy you should buy and things like that. So all that is coming from, kind of cognitive automation you get, or you might have seen some cognitive automation in your other social company, social platform company. So that's all is now, but now that is being combined into our industrial or home automation or factory level automation to get better benefits. Then so this is what I say is a robotic cognitive automation program.
What is intelligent automation? Simplicity is complexity resolved. Intelligent automation stands as a newfound way for you to streamline and optimize processes at different levels of your business through automation and cognitive capabilities. It is a three-way framework of technologies that bring high mobility and unison across teams. They are robotic process automation, business process automation, and artificial intelligence. Robotic process automation allows you to emulate the way people perform back-end, high-volume processes, all through a set of defined instructions. These rules help the bot perform repetitive and time-consuming functions on its own. A few examples would be creating accounts, modifying customer information, automating customer refunds, processing feedback and complaints. What's more interesting is that you can teach your task-based RPA system to correct or adapt its course based on its performance and dynamic conditions in the shortest times possible. This is truly what businesses such as yours can benefit from: accelerated efficiencies. Business process automation, on the other hand, looks at a much larger picture. Imagine a company with process gaps across departments impeding it from performing to its full potential. There is a discord between worker onboarding, invoicing, supply chain, and retail. All of these departments are standalone but highly impacted by the way others function. BPA works at filling those process silos to form a coherent and sustainable business network. RPA and BPA form the backbone of automation, but they are not cognitive, but artificial intelligence is. It is the third component of what really makes automation intelligent and perceptive. With the help of machine learning and neural networks, AI decodes patterns and draws meaningful conclusions out of unstructured data. It is self-improving and requires minimal human support. With continuous training and deductive reasoning, it is able to evolve to become more human after each application. For example, with the help of sentiment analysis, natural language processing and understanding, conversational AI is able to pick on the intent, tone, emotion, and even urgency to enable human-like customer support conversations. Intelligent automation can be applied across industries to make collaboration easy. In retail, you can use it to bring manufacturing and sales together. You can intelligently manage purchases to ensure adequate inventory, automate returns and send timely refunds, communicate with users clearly, and even navigate their demands through predictive analytics. In a data-sensitive industry such as healthcare, intelligent automation can assist with keeping a safe record of patient data, assisting cross-departmental transfers, and scheduling consultations and follow-ups all autonomously. Another industry in which data protection is paramount in financial services. Most day-to-day banking functions like answering FAQs, customer onboarding, account management, and loan processing can be easily and smartly automated. Intelligent tools can also map risky user behavior to detect fraud before it occurs. But how does a business benefit from using intelligent automation? The possibilities with intelligent automation are limitless. Time and efficiency are central to thriving companies today. With the right approach to automation, businesses can yield more ROI and higher economies of scale. It can lower your operational costs, reduce human error, ensure more data accuracy, lead to employee satisfaction, happier customers, and increase your adaptability to market shifts.
So you can see the kind of, automation in the different industries, and at the software side, at hardware side, are combining both rule-based, cognitive, right, AI-based. Different kind of automation. So the highest level of automation would be definitely autonomous automation, autonomous operations of machines that independently, without human intervention, operate. Kind of example I already gave is driverless cars, right? So this automation would be very widely used in the beginning, probably in transport, logistics, agriculture, many other things. But it will take some time because a lot of things need to evolve and understand. But slowly, at small level, like I just gave an example of warehouse, right, or where the complexities are less probably. Then the autonomous automation can be useful and helpful. So here is one example which I was working when I was at Wipro, and this is the company we were collaborating. When I was working for autonomous vehicle, we were collaborating with this company to build this, help them in this. So this is a vacuum cleaner, autonomous vacuum cleaner. So you might have seen people doing vacuuming manually, but imagine the large spaces you want to do continuously, or the countries like US, UK, or European countries where manpower is not there, and it is manpower is costlier than the machines. So in those situations, probably these kind of autonomous intelligent machines would be useful. So that is a kind of automations happening across the industries. There are different levels of automations happening. So just briefly, let's go. What is industrial automation? It's a set of, we already talked about this. What is automation? It's the same, but specific to the industrial application. Uses hardware and software control system devices or robots to operate or to work in industrial processes, industrial setup, industrial operations without human operator, right? So benefits, some of the videos you already heard. Just to recap, it reduces your cost, enhances quality, gives accurate results repeatably. Its communication is better, faster. Equipment monitoring you can do. You can increase the productivity. You can increase the safety. You can have better working conditions. Do the predictive maintenance, corrective maintenance. You can trace back your production. Many benefits of automation over the traditional manufacturing or traditional industrial operations. So how these automation systems are built, what is that standard typically used, right? So ISA, International Standards of Automation 95, is the standard used, defines the fundamental hierarchical model for building automation systems or integrating the enterprise and control systems. So there are two things in the automation, right? There's hardware, software, and your company, your process, right? So that control system is connected to the enterprise system, and how it should be done. The guidelines are defined in ISA 95, and that helps to people design the whole communication, and various models are given in the standards. Not just, I'm going to explain here only the fundamental model and how it has now evolved in the changing world. And it's a layered pyramid level layered technology or business process models. It can be functional model, it can be technology model. I'm going to follow, I'm just briefly going to explain what is that, and then you can probably refer ISA standard for more detailed understanding. So it is a layered.
So what exactly is the automation pyramid? It's a pictorial example of the different levels of automation
So there are 5
in a
levels.
factory
There are
or
5
industry.
layers. So field level, that's the bottom. Control level, supervisory level, planning level, management level. As you go from the shop floor to the management level, the different kind of devices, different kind of processes, different kind of time zones are addressed through this. And this is applicable to any industry. It's not just manufacturing. It's not just, any industry can adopt this kind of automation pyramid. So there are, as you have seen, 5 levels of automation. That is the level 0 is field level, where actual process is happening. And level 1 defines what are the activities required to, it's a process level, where you have to do the sensing or manipulating of the physical process. Level 2 is doing the controlling and supervising of that supervisory level, where you want to control and supervise, monitor the activities. And level 3 is activities, you want to define the workflows of the activities to produce the desired results. And level 4 is a management business layer. So this is briefly explained here. Let's
On the bottom of the
with the
pyramid
examples
is
and
what
with
we
the-
will
with
refer
the-
to as the field level. These are the devices, actuators, and sensors that you see in the field or on the production floor. If you think of it this way, the field level is the production floor that does the physical work and monitoring. Electric motors, hydraulic and pneumatic actuators to move machinery, proximity switches used to detect that movement or certain materials, photoelectric switches that detect similar things will all play a part in the field level. The next level is referred to as the control level. This is where the PLCs and PIDs come into play. The control level uses these devices to control and run the devices in the field level that actually do the physical work. They take in information from all of the sensors, switches, and other input devices to make decisions on what outputs to turn on to complete the programmed task. A PID is usually integrated into the PLC and stands for proportional integral derivative.
There is a MPC
That is
controller.
what can keep a variable within a set of parameters. A common example that you probably use every day is your cruise control. You set your cruise control to whatever
Or in that
speed you want,
boiler operation,
then a set of
the PID
sensors and
controller
the computer in the
asks you.
car will tell it when to accelerate or decelerate according to the set speed. A common industrial PID controlled item is a heater. Many systems in manufacturing plants have to be heated. We control this with a PID block within the PLC. When a set point is entered, the PID will determine when the PLC needs to turn the heater on and off to maintain a constant temperature. The third level of the automation pyramid is known as the supervisory level. Where the previous level utilizes PLCs, this level utilizes SCADA. SCADA is short for Supervisory Control and Data Acquisition. SCADA is essentially the combination of the previous levels used to access data and control systems from a single location. Plus, it usually adds a graphical user interface, or an HMI, to control functions remotely. Water plants will often employ this technology to control remote water pumps in their systems. The important thing to remember about SCADA is that it can monitor and control multiple systems from a single location. It isn't limited to a single machine like HMIs that we've discussed in previous videos. The fourth level of the automation pyramid is called the planning level. This level utilizes a computer management system known as MES, or Manufacturing Execution System. MES monitors the entire manufacturing process in a plant or factory from the raw material to the finished product. This allows management to see exactly what is happening and allows them to make decisions based on that information. They can adjust raw material orders or shipment plans based on real data received from the systems we talked about earlier. The top of the pyramid is what is called the management level. This level uses the company's integrated management system, which is known as the ERP, or Enterprise Resource Planning. This is where a company's top management can see and control their operations. ERP is usually a suite of different computer applications that can see everything going on inside a company. It utilizes all of the previous levels of technology, plus some more software, to accomplish this level of integration. This allows the business to be able to monitor all levels of the business, from manufacturing to sales to purchasing to finance and payroll, plus many others. The integration of the ERP promotes efficiency and transparency within a company by keeping everyone on the same page.
So that's a pyramid automation architecture. advocated by ISA 95, and which is something similar, if you remember, right, from my second talk where I talked about digital twin, and I said digital twins are built on Industry 4.0 architecture, and you see that there is a physical layer, communication layer, platform layer, and application layer. So, but the way probably it works is slightly different than the ISA 95, but by recognizing this need, that ISA need to be upgraded because PLC and SCADA and DCS are now kind of old legacy systems with changing technologies, IoT systems coming into picture. Probably it's not going to work the same way. So ISA has evolved the model now, and it has the old hierarchical architecture is now converted or being promoted as new network architecture model to address some of the needs of Industry 4.0 architecture, and or to address this Industry 4.0 needs, to embed Industry 4.0 architecture or technologies or systems into that. So ISA has now upgrading their new for smart manufacturing or smart MES or smart MOM operations or implementations. It is now advocating, or it is suggesting to adopt this new network architecture, which has all connected devices, which has all kind of data processing layers, which are all interconnected systems, AI systems possibly, and all that. So it will try to add, it will try to fulfill the needs, standard needs of the factories which are adopting Industry 4.0 and automation. So what are the steps you can start? Probably you can start by planning different. First it starts with the planning, then verifying, implementing and verifying, and then execution, right? So planning, then doing verification, then execution and planning, and then after deploying, training to to employees to use, maintenance, performing different maintenance, all that. So it's a 4-step process, but it's easier said than done. Definitely, you'll have to study the detailed process, how you can automate, what are the challenges to automate, and all that. And then when you build the automation, the assembly, it will definitely a larger execution programming will be another larger task. So deployment might be probably easier, planning might be easier. So one of the example, very early days of industrial automation, which I work, is real-time seam tracking system for automated fusion arc welding. So that was a kind of setup. I mean, when I was doing my master's in IIT Bombay, as I said earlier, I had since beginning, I had very much interest into the emerging technologies, and even during that 99, I was, although I was a mechanical engineering student, but I did my BTech project was in a software. I implemented quality control. I developed a software for quality control system using P-bar chart, P-chart, R-chart. I don't even now remember the names. What are those quality control charts? So then when I went to the IIT Bombay for my master's, MTech, so I got another opportunity to use do this automated welding using. So we had this welding machine to let's say we want to join the two parts. We want to join, let's say, two parts like this. Now, typically the person, typically the welding operator will look at the seam and the weld, right? And now it's a there are two things, right? We said in the beginning, it's a repetitive task. If it is a seam is too long, imagine, right, to weld, it will be too boring to do. That's one thing. And welding itself is a dangerous task. So to address both of that, and to do this in automated manner, we thought, and see, if as long as the two plates are straight, as long as two plates are straight, probably we could have done fixed automation, right? Because then we know what is the fixed position of the rod, all that. But we wanted to do it for any general joint, right? It can be curved plates, or it can be inclined seam, or it can be any kind of seam. So how do you do that? And then we had we had bought XY control table, and we had a thermal camera. So thermal imaging camera, and the welding torch is fixed, and it detects, thermal imaging camera detects the welding rod tip, as well as joint ahead, and then do the real time. That's why we say real time seam tracking and real time detection of the joint location where the welding should take place. So if the torch is offset from the joint location, it will automatically shift the plate in the control system, stepper motor control system. We had this PLC card within which was programmed, and control actions was sent, right? So, based on the image processing which we do and identify the system. So this is what the whole process was. So you get the CCD camera, you initiate the stepper motor control system, and set up the welding parameters, apply the welding, start the welding by putting the plate, it will do the it will process the images and identify. So that's what it will identify the weld tip, it will identify the joint location, and then it will identify what is the gap. Is that center of this seam weld tip is at the center of the joint or not? If not, the stepper motor control will move this table in X and Y direction. One direction is continuously moving seam ahead, and the another direction try to keep the motor at the center of the seam. Even if it is a inclined or circular, it will still do the. So we performed several experiments. So you can read the paper, and here I have given the details of the paper, and you can read that paper. This was a kind of industrial automation we did early days, and that was one of the experience. And then I did that robotic platform which I talked that day, Monday, right? In a robotic automation, lot of robotic automation or autonomous kind of automations in a Bhabha Atomic Research Center we did. I just did not want to repeat that, so I did not really brought that here today. So then, if you remember, on the first day during introduction, I talked about some of my skills, right? So I said I'm a core mechanical engineer. I did a lot of work in CAD, CAM, CAE, and then I also worked in software development. So one of the work which I predominantly do into, if you see here, it is known as the knowledge-based engineering. So what is this knowledge in engineering? So if you remember, if you see here, it says automation and scripting for various tasks. So it was on a software side automation for these core softwares. So in a designing phase of the product, so the automation which we are talking until now is the automation at the factory level, right? Manufacturing operation level. But before manufacturing the product is designed, and the product design itself is very complex. Think like aircraft systems or automotive systems. They are very, very complex. So for designing using CAD, CAM, CAE, we used to do a lot of automation. And that generally is known as a knowledge-based engineering by a Boeing. In a Boeing, if you go Boeing website, you will come across a separate department known as a knowledge-based engineering. So we applied this knowledge-based engineering or automation scripting in a knowledge-based engineering for these core engineering tasks. So I have been doing this across the product life cycle, aerospace, automotive, lot of CAD, lot of FEA, lot of CFD, lot of all these processes. And different softwares I have been using, different analysis we have been performing, right? If you see the systems and what happens in today, if you go any company, lot of digital technologies are being used, CAD, CAM, CAE, of course, because it gives a lot of advantages or traditional prototyping technique, right? You don't want to design and manufacture without really doing a digital design using CAD, CAM, CAE, digital design and validation. So and that saves a lot of time and effort for the company. So many companies are now heavily rely on CAD, FEA, CAM, and Boeing is one such company, which is, or aerospace is one such company which heavily uses that. And before you manufacturing the first prototype, lot of digital CAD based, CAE based, CAM based iterations happen. And every time you want to do the CAD modeling, every time you want to do the simulation, every kind of do the CAM simulations for the similar kind of product, right? For the similar kind of product, it is very time consuming and repetitive in nature. So how do you save that efforts? How do you do the task faster? And to do that, you can automate many of these tasks. And we were, and apart from traditional simulation, I did a lot of medical device simulation also, and used automation in design development of the medical devices too. So what is this knowledge-based engineering framework or automation framework? So it is so what is our traditional design process? Concept, design, realize, sustenance, right? And if you see traditionally, let's say if it takes 100 hours, let's say it takes 100 hours traditionally. So now knowledge-based engineering, if you embed that knowledge of automation and scripting and do the automation and scripting to the repetitive CAD modeling, repetitive FEA, CFD simulations, or repetitive manufacturing simulations, then it is observed that you can reduce almost 80% of efforts. You can reduce the 80% of the efforts. So overall saving can be 20 to 40% savings can be definitely there. So from the traditional 80% task, 80 hours, let's say I said 100 hours, out of that 80 hours a routine task, that can be brought down to 20, 30 hours. So you save that, 50, 60 hours, right? 50, 60 hours per task. And that is a huge, around 80%. And then you get more time for your creative thinking, right? Creative thinking. So that helps you to reduce the cycle time, effort reduction, streamline automated processes, consistent and standardized designs, reduce person dependencies, quality improvement, similar to what automation benefits you had earlier. And this is one example. This is one example where, now gear, right? Gears are standard shapes, geometrical shapes, right? Which probably. So what we did in one of the application, we asked user to input their requirements, and based on the requirements of gear design, helical or spur gear, or what kind of operation it is, and lot of power requirement, many material, all that input you will take. Now gears are typically designed using AGMA standards. So behind it will automatically do the all AGMA calculation. You need not to do anything, and validate, come out with a safe design of the gear based on AGMA. And now this design, you can probably, what you can do is automatically it will create the CAD models. I don't know why it is happening. Let me share again. So you can see these CAD models are automatically created, and then in the back end, the FEA simulations are automatically done. So you need not to do, just enter the parameter, you get the design. So now the process, which was, let's say, taking 100 hours, is just done in 5-6 hours. So it's so fast. So that's one example. And then we were doing this kind of design for many other. So in a corrosion analysis of a pipe, we use the same approach. So creating this profile of the actual profile of the corrosion was a tedious or difficult process to do manually. So what we did is we captured the rule, defined the rule in the program, and now using this knowledge-based engineering or automation scripting, it is done very efficiently and effectively, which can quickly help you to generate the same thing we applied now in this. This is a chassis design, in genset chassis design end to end. I mean, something similar to gear. I don't have the details of this because this we did in Infosys for a customer, and the details are not with me. But it was like user gives input and you get a design report created without any intermediate manual task. So that kind of automation we did into this for chassis design. So it will do the efficient chassis design. So these are the other kind of automations which you will come across into the industry, more on design side, software side automation. So I said one more automation which is a very popular in IT side of industry is robotic process automation. Let's see what is it.
This is Jim. He is an accountant in a multinational company. He handles several invoices and other financial records like monetary transactions, liabilities, checks, and ledgers on a daily basis. One of his tasks is to copy all the relevant information from these invoices, such as the name of the company, invoice ID, and date of processing into a spreadsheet, and mail the sheet along with other financial reports to his superiors by the end of the day. As any prompt employee, he transfers all the information to the sheet, attaches the reports, and sends them over to his boss via email every day. But over a period, he starts finding this task to be time-consuming and repetitive. Frustrated, Jim looks for a way to reduce the time and effort it takes to complete the task. And voila! He stumbles across robotic process automation, aka RPA. Using robotic process automation, he builds a simple bot that extracts information from several invoices into an Excel sheet, attaches all the necessary financial reports, and sends them over to his superiors via email at a specific time every day. So, what exactly is robotic process automation? Robotic process automation, RPA, is the use of software with artificial intelligence and machine learning capabilities to handle high-volume repetitive tasks that previously required humans to perform. Some of these tasks include addressing queries, making calculations, maintenance of records, and performing transactions. There are several misconceptions about RPA. RPA is not a humanoid robot. It does not have a physical form and no resemblance
so
to
that
humans.
you need to understand.
RPA
Mechanical
cannot
engineering might
replace
get
humans or
confused.
replicate
RPA
human
means a
cognitive
robot
functions. It
deployment
does not
of
have a
robot.
brain of its own, and cannot perform logical or critical thinking as humans do. The working of RPA includes 4 crucial phases. 1. The planning phase typically involves gathering the processes to be automated, identifying the test objects, and finalizing the implementation approach. 2. The development phase includes the creation of automation workflows as per the agreed plan. 3. Deployment and testing is a vital phase, since it uncovers any unexpected outages and ensures a bug-free product. 4. Lastly, there's the support and maintenance phase, which ensures that the product is continuously updated with smooth deployment across the user base. To meet the objectives of RPA, tools are used. These RPA tools are software applications that can configure tasks and automate them. Some of the popular RPA tools in the market are UiPath, Automation Anywhere, Blue Prism, WorkFusion, Pega, and Redwood, among others, leading to the area of deliver experience
So
and
I'll
ensures
probably, in the
24/7
interest of
business
time,
continuity.
I wanted to give, so this also I'll skip. I thought I'll talk about this. I write a blog. When I shifted to UK, maybe quickly I'll give a brief, how do I use automation into this kind of robotic process automation. So when I used to write a blog in India, and that is more for helping my daughter in her studies. And when I shifted to UK, a lot of people started asking me, how can we also look for the jobs in UK? And it was very becoming difficult to tell everyone on WhatsApp, phone, right, or very different LinkedIn platforms and all. So what I thought, I'll create some pages on my. If you see here, it is jobs in United Kingdom, and I started people helping, and then initially, like last year, it is almost a year now, I started this activity. And initially every Saturday, Sunday, I used to sit, create, extract the available jobs in UK universities, list them on different pages of my blog. 1 or 2 pages I used to create, and that used to take my whole weekend. Okay. Now, over the period, I realized, because I come with this automation background, and I felt, why I'm doing this again. After a month or 2, I realized, no, I should do some automation. And I started doing automation. And now you can imagine the task which I was doing in the beginning and creating only 1 or 2 pages. Now I am doing that through automation, robotic process automation. I update every weekend almost 150 pages, because I added a lot of features into it, and through automation process. And I just do in a couple of hours. I just run the script, it extracts the information from different internet sources. It creates the different pages, HTML pages. It will push the HTML pages to my blog automatically, and done. So I'll send you the link if anyone interested can see. So there is an intelligent automation, we said cognitive automation, and I'll briefly spoken. So one of the case study which our when I joined in UK, my research center, we did this. So there is a prior lot of work. This is a video to that, and then I'll talk about what I did. Intelligent. How did we use AI into that?
We're here this afternoon to witness the final demonstration of the AWESIM technology, which is Automated Welding Equipment System Inspection and Monitoring Project. The purpose of the project is to develop a system for real-time weld process monitoring and associated near real-time and non-destructive examination of the weld as it is formed using phased array ultrasound. The key successes for this project have been dealing with COVID, which we have done, but dealing with the challenge of managing huge quantities of data and integrating that data together. Also, it's the real-time viewing of the data and being able to interpret that data in a really easy way so that the operators get that immediacy of feedback from the process, from the system.
This project, AWESIM project, is going to change the way high integrity multi-pass welds are done throughout the world.
AWESIM, in terms of inspection and welding, presents a massive opportunity for us to allow to decouple traditional processes that we would do through being able to inspect at temperature, also have insight from welding sensor and data.
The AWESIM programme for us has been a culmination of quite a few years of work that has primarily been sponsored through the Advanced Manufacturing Materials programme through BASE.
Collaboration is key to ensuring that the success of these projects, and we're translating fundamental research through the technology readiness levels to industry. The collaboration in this project, where we have an industry leading the technical requirements, government support providing the necessary funding leverage to enable this to happen, and the academic teams engaging collaboratively with all those parties to deliver meaningful transformational change and deliver impact on the shop floor.
What we're able to do here is, as we're welding and depositing the welds, we are actually testing. So we're getting very early indications of any defects. So if anything has gone wrong, we don't have to scrap the full component. We don't need to excavate a very large part. We can react very quickly. So the time between defect formation and defect detection has been really shortened by this project.
Any high integrity welding process will need to have the AWESIM system attached to it if you're going to competitively compete for work.
So in this traditional welding, they use different sensors like laser sensor, camera sensor, ultrasound sensor, different kind of sensors, and they were processing the data in more real time. Now, how did we made intelligent? I mean, when I joined, I tried doing it more intelligent way. So what we did is we built artificial intelligence model. Traditionally it was done like you can see the defect can be seen. A good weld needs a cleaning, and defective weld, and the AI model, artificial intelligence system model, is built, and now that is integrated and will definitely, you know, is intelligent than earlier, which earlier was more of a rule based. You process the data, define the rules for the defect detection. Now it is more artificial intelligence, reasoning like human, and then taking the action. So that kind of, probably in the interest of time, I decided I'll briefly talk about what is AI and all, but probably we don't have that much time. I think we are almost done. So I hope maybe we can stop here and I can take questions if there are any. And messages, yeah. So there is one question from Mr. Sonar. Sir, can you please suggest computer-aided process plan, open source software, MRP, material resource planning software, there are many softwares, but I mean, you want to open source, probably I'm not aware. Okay. So maybe I'll try to find out. I'll just take note of this. I'll just copy this and I'll pass this information to BC sir and probably, but I don't remember. I don't know the open source software. There are many commercial softwares, but not definitely. Sorry for that inconvenience, but I'll pass on this information over the weekend to BC sir. Any other question? If no question, yeah, you can email me, and this is my email ID, tparley@gmail. Right, and so any more questions? If not, over to BC sir. Thank you once again for listening me. I hope it was another interesting, enjoyable session for you. If you need any, if you need anything in these areas, you can definitely reach out to me. You can contact BC sir to take, if you are not noted down my numbers, but probably in the recordings you can find my email ID number. That's WhatsApp number. My number is not really UK number. I have not shared, but you can contact anytime on WhatsApp, and anything you needed to mechanical, to software, to research, to I'm there to share my knowledge, experience. Thank you, BC sir and management, for giving me the opportunity once again to talk on different interesting topics. Thanks. Over to BC sir.
Thank you so much, sir, for deliver such a nice session.
Okay.
Thank you, sir.
Thank you.
Okay.
Okay. Thank you. Bye. Bye. Bye.
Bye. Bye. Okay. Good morning, everyone. Myself, Mr. S.S. Patil, Head of Department of Padma Shri Dr. VBKCOE College of Engineering, Malkapur. So now we are moved towards our last session, that is vote of thanks. It has been such an honor to be a part of this wonderful program. On the behalf of organization, I would like to extend my heartfelt gratitude to our guest, Dr. Dattatray Parle, Dr. G. Srigar, M. Raja Chandrasekhar, Dr. G. K. Auri, Mr. V. Y. Sonone, Dr. Rucha Kolekar, and all the participants. I am also thanks to Institute Management and our Honorable Principal Dr. A.W. Kharche sir for giving this opportunity to our department conducting such a wonderful STTP. And finally, I would like to thank the host of this program, Mr. P.B. Vise sir and their entire team. I hope we all are connected to each other for like that programs. Thank you. Thank you so much.
Good morning, all. Participant, please note that feedback link will be shared within 10 minutes, and overall FTP feedback link also share within half hours. So it is mandatory to all participants to fill feedback link so that certificate will be automatically generated. Okay, and once again, thank you so much all participants for listening our STTP. So our STTP will be end today. So it is declared that our STTP is finished. Okay. Thank you.
Okay. Thank you, sir. Patil sir.
Okay.
तो एवढंच होतं ना व्हॅलिडिटी सर?
हो सर, हो सर.
ठीक आहे, थँक्यू सर. मग आता लिहू करू शकतो आम्ही? लिहू करू शकतो?
हो सर. ओके.